people assume that you eat food and it is automatically energy, but there's this gap. And what we need to do is close that gap to make it more efficient with the fuel coming in, converting into energy, and us running like a nicely fueled machine. But it's more of that broken metabolism and the ATP and the mitochondrial health. So whether it's a vegan diet, a carnivore diet, a paleo diet, whatever it is, the goal is to increase ATP and mitochondria and fix that metabolism. So what are the things that have broken that metabolism?
Yeah. And as you're getting at too, we keep blaming the fuels, right? We see this extra glucose in the blood and we're saying, well, we keep taking in too much glucose. And the problem is actually just that we're not using it effectively. So then instead of recognizing that, we take out all the carbohydrates and we go on a low carb diet. And maybe it helps short term, and it'll definitely help to lower our blood sugar for the most part short term, but comes with a whole host of other negatives. And that's because we're not actually fixing the underlying problem. We're not actually improving our capacity for converting the fuel into energy. And there are a lot of different factors that come in there. One that is talked about a lot is the polyunsaturated fats. The way that they're talked about in a lot of the health circles these days is as the seed oils, which have very high amounts of the omega-6s. And the polyunsaturated fats, when we use them as structure in our cells, lead to a much less efficient engine. And we can discuss those details, but this is one of the central pieces. Basically, the more polyunsaturated fats we have as a structure of that engine, the less efficiently it functions, the more reactive oxygen species we produce, the more lipid peroxidation we produce, and the less effective ATP production we produce. It's basically just a much less efficient engine. And that's one of the central concerns. Another one, which is talked about a lot less often, is endotoxin. And endotoxin is a component produced by bacteria in our guts or anywhere, and it really effectively or dramatically impairs our mitochondria's ability to produce energy, to the point that if we're exposed to large amounts of endotoxin from a severe infection, it is actually responsible for causing sepsis and then death. So it's a pretty potent metabolic inhibitor, basically. And what's found is that more moderate levels of endotoxin, not the extreme amounts that we find in sepsis, but more moderate levels are found in insulin resistance, metabolic syndrome, cardiovascular disease. We see it inside the actual plaque in the arteries. So we see this kind of crop up everywhere as one of another primary driver of this state that prevents us from effectively converting that fuel to energy and instead redirecting it to store it as body fat. And so I'd say those are some of the, two of the top ones, the primary ones. But then there's also things like nutrient deficiencies, right? If we're not having the nutrients that we need to convert fuel to energy, which is everything from nearly every B vitamin to magnesium and zinc and copper and iron, and pretty much any vitamin and mineral you can think of is involved in the energy production process. And so nutrient deficiencies can be a major one to impair the conversion of fuel to energy. Anything that creates oxidative stress and inflammation will also impair, because the enzymes will impair energy production, because the enzymes that are involved there are very sensitive to oxidative stress. And basically when the cell is inflamed, the enzymes turn off. And again, I mean, some of the things we're mentioning here do that, but there's a ton of other aspects of our environment, whether we're talking about anything from heavy metals to non-native EMFs to going a long time without eating, excessive blue light. There's a ton of different factors here that will end up also blocking energy production.